right, so thank you guys for joining. Today we're going to be messing around with Project Euler. So what Project Euler is a, let me pull up the website, actually, that might be helpful as well. What Project Euler is a sort of a puzzle site that gives you a library of basically math riddles and puzzles to solve using your programming wits, I guess. So all the problems progressively get harder. So you'll learn something in one problem. Say you're doing something with primes, and say you have to get like the 10th prime number. Later on, it'll ask you, well, I want the sum of the first odd 13 primes, or first not odd, first whatever primes, and because almost all primes are odd, but anyways, so in other words, it's a big library where you can go and just sort of solve puzzles. It's always been a passion of mine to solve little puzzles and figure stuff out. So this is just another way to practice your programming, and this is really important with just the core programming knowledge, not necessarily how do you center something on a page or how do you do this with HTML. It's like this is just core. How do you logically think like a computer so that you get what you want? And I think that's a big part of the interview process in general. So a lot of times you'll go into an interview and they'll just be like, all right, here's this problem, here's this array, do something with it, or do XYZ with it. And then you'll have to think how to do that either on a whiteboard or more recently, they'll do a live programming session with a member of their team. So it's all very important. It's all fun. So we'll just take a stab. So this is actually chapter 2 of this session. So in the first session, we solved problems 1 through 3. So that's why you'll see in the archives here, we actually solved the first 3 problems. So we're going to head into the 4th problem and give it a tackle. You guys have any questions?
Not yet.
Cool.
I'll jump in and say that you can actually find the old, or not the old, the previous chapter on our YouTube channel. So I'll post the link in chat, but I don't know, James, if you want to show it on your screen at some point, maybe towards the end, but
yeah, so, well, I can pull up the repo too towards the end too, just if we get to that point. Yeah, for sure.
Yeah, but I'll just I'll post the link in chat so everyone can see.
Yeah, that sounds good. Yeah, so what I'm doing here, so what I did is, so in our repo we have all the libraries from every session we do, we add it to the repo in its own folder. And what I did is I took session 12 as the Euler part 1. I just grabbed the code from there and dumped it into Euler 18 to just basically part 2. So that's where we're starting. The only thing I did just to help us move along a little faster was pull out a function. So essentially all this code here was what was right here, basically. So I wanted to use this because I knew we were going to do primes soon. So we were going to hit prime numbers again. So I just wanted to grab that and make it useful for us later on. But let's see what the first problem is, and we'll take a stab at it. So palindromic number reads the same both ways. The largest palindrome made from the product of 2-digit numbers is 9009. All right, so find the largest palindrome made from the product of 2 3-digit numbers. All right, so right away, like what is it? If you guys can sort of be assistants to me here, what's the first thing that comes to mind when you got to tackle this problem?
What is our bounds?
What is our bounds? Sure. Okay.
So there are 2 3-digit numbers that are multiplied together. So I'm thinking, so it's going to be higher than 100 times 100 and lower than 999 times 999. So if we get what those numbers are, we at least have an area where we're heading towards, and perhaps from there, like, is it going to be 5 digits? Is it going to be 6 digits? 7? Where are we?
Does it matter?
Well, let's see. Let's say it's 90,000. If it's 5 digits, we might get 90,092, or if it's 6 digits, we might get 112,112, or it would be useful. At the very least, that's a good point. Does it matter?
Do we have to do string comparisons to solve this?
Do we have to? No. Are you asking me?
Yeah,
No, we don't have to.
really. That's the first thing that jumped into my head was to split the string into either like single
Arrays of characters.
Yeah.
Yeah, so that's definitely the first approach I think anyone should take, is definitely just look at the characters itself. But you, like I said, you don't have to. You can compare digits. You can take the number and take modulars of the digits you need, and then just compare them forward, front to back. And you could, in theory, compare those numbers, but that's not necessarily the best way to do it. So we'll just go off of what feels comfortable between us. I've done all these problems before, not necessarily very recently, but I know they're doable, and a lot of people have done them too, so I'm sure we can tackle it. So that being said, we need a palindrome. So a palindrome is obviously some number, so 109091, right? So we know that the number we have to test whenever we do this math, these two multiplication numbers, so that we have to see if it's a palindrome. So I think the first thing we could do is just make a helper function that returns true or false if that number is a palindrome. I think that'd be the nice, helpful is palindrome. So, and we should take we'll just take a string here, just because value.
I'm interested in seeing your solution without strings, because that would be like 50 million times faster than
comparing. Yeah.
poly conversions.
Yeah, we can play with that. I definitely add that. I can add that later on my own time and try to see some, because that's definitely a lot more code, just because you have to do a lot more math to make those comparisons.
Benjamin is a math person.
Well, that's good.
Keep in mind, it has been at least a year since I've been in college, but
well, it's been many more for me.
For most,
so.
Yes, I understand. I
know programming can be weird about math, but the symbols are usually the same.
Yep.
Right. So okay, so is palindrome. So we got a string value. So what do we know? What can we do with this value to split it up?
Split up. Is there not a dot split function?
String list equals value dot split in a value dot split string dot empty. So that we just get a list of.
We would need to get the length of the string itself, so we could split it straight through the center. And then even then we'd have to reverse
length is
it.
Good.
Length of the string would be the same as the length of the list when we split it. So we don't, because the thing is, it could be 5 digits palindrome.
Right.
So if that's the case, then what we would do to compare.
Oh, I see what you're saying. So if it's if it's an odd number, we would have to kick out the center digits.
So if it's even, we're looking at 3 numbers that are relatively easy to compare. When it's odd, we're looking at 109.
We're really looking at two digits.
901. Or 9.
Yeah, because in an odd situation,
so this number here doesn't matter. It'll still be true, right?
Yep.
So that'd be the
if we
first
have
thing to do is to kick out the middle. Middle part of the value.
Yep.
That's an option. So let's think about whether or not let's think what tools we have as far as how do we iterate through this string. Strings inherently can be accessed via like an array index, right? So if you go value, of 0, you're going to get a character, right?
Oh, that's right, because a string is just a wrapper for an
just
array
a string array of characters, right? So let's go with the idea that we want to compare those indexes. So we'll do for int I.
Oh, I think I see.
I is less than what? Obviously, we can't go farther than the length of the array.
So it's just that array.length or
right.
Do we want to do a loop?
We don't, like I said, we don't have to. It's just a matter of what it can conceptually we can come up with.
So I think we might actually be able to do it length divided by 2.
Right. Except it's where it's odd, so that's where we would want to.
We would just have to
Well-
compare array like position I to array position length minus I, or something like that.
Yeah, that's a really good idea. Here, so if we did something like, where am I looking at? Value I. We can check to see if this is equal to value.
I think for string you have to do
Length
dot
minus.
equals, but yeah, I'm not sure.
Well, they're just characters, so
Okay.
it'll be fine.
Okay. Right, because I'm thinking full that
minus
compares
I.
equals.
All right.
Oh,
My
because
So,
apologies.
so where does this break? Why does this break? Tell me why this isn't correct.
no semicolon. Rather.
No. Well, I mean, besides that, val q equals
There you go.
var. All right. So why is this not a valid statement? Why is this going to break right off the bat?
Value 0 equals value.
Oh, it's a value one above its length,
Yeah,
basically.
because it's going to be out of bounds right away.
Right.
Yep.
This one's going to be out of bounds because this is exactly one above its length. So we'll just do add a -1 here.
Mhm.
Be good to go there. All right. So what this does is this checks to see if that value is true, right? So if it's true, we can continue, I would say.
What if can I offer a syntax thing? I would actually skip that intermediate variable.
Yeah, we're not going to keep it. Hold on.
Uh,
All right. So assuming we go this route, how will we stop? One way to or at least one way to stop it is we just ensure that this is true. So at any point, if we are either beyond the length of the array, and if the is palindrome Boolean is false, then we will then know if that string was not a palindrome. So so then we would return this pally.
Yep.
Does that make sense?
Does to me.
I would. Can I offer my suggestion?
Of course.
Just inside the for loop, if val I does not equal the value length -1 minus I, return false, and then at the bottom return true. Because return false will automatically break the loop.
Yes, it will break the loop. Well, that's the idea. That's what we want, right?
Well, without having the cognitive overload of the intermediate variable, because now you have to look in like 4 different places
I see.
versus just the 2 return statements.
Right. So you're saying if this is here,
If that's not true, if it does not equal, then just return.
yeah,
Mm.
Control X. But is that going to work? Like if you do this?
No.
Well, not in the for loop. Just
like
in
rid of-
play.
Yeah, so get rid of your is pally stuff,
Sure.
and then just put in at the bottom, do return true, and then inside the for loop, do an if statement, and your
Got it.
if block will be for the value, and what you're trying to do is see if they're not equal.
Okay. So yeah, the return. Basically, I can return. No, not return. Sorry.
You have to do it inside an if block. So that
So
would be
if this is
return
equal,
not
then we can just do that. Return false. Right.
Yep. Mhm.
Cool. So we can ditch those. All right. So let's just give this a whirl just to give it a try. Just to make sure our helper function works. We'll do is palindrome of 10001.
Dude.
Hold on. There we go. All right. So in theory, we should get true here, right?
Theory.
Sweet. All right, so is palindrome looks to be valid with odd numbers. I mean, obviously this should work if it's even. So if we do 11. I have complete faith it'll run. So I'm just going to scroll up and go to problem 4 here. And this is saying, what was even our question here? So it says the largest palindrome of two 3-digit numbers. So we're basically looping through equals some number. Where do you want to start? 0 or 999?
Do you want to loop down?
We're starting with the largest number going down. Is that what?
That would be faster. Do you want to? Are you going to do 2 loops?
Yeah, you would have to iterate through both.
So the outer one would be I equals 999. The inner one would be J equals 999.
Exactly. Less than or greater than. We have to be greater than 999 because we have to be 3 digits.
Yes.
And then I minus minus. And for int j equals. J is greater than 99, and then j minus minus. So then we just check if this is a palindrome.
Yep. Is palindrome I times j?
Yeah. I times j.
I have a question.
Sure. Shoot.
This seems to be this function that we just built here. It seems to be checking if the what's the large. Okay, I kind of just answered my own question thinking about it, but it seems to be finding what the largest palindrome, like the largest 2 3-digit numbers are that creates instead of what the largest palindrome is. Like I felt like we should start with 999 and work our way to these 2 numbers, but as I thought about it, I just realized I answered my own question. That if we have the 2 largest 3-digit numbers, it obviously becomes the largest.
Right. Now the only problem with this loop is you're not going to guarantee you're having the 2 largest numbers at any point in the array, because only one of them is going down at a time. So at some point you'll get down to 999 and 100. So obviously those aren't the 2 largest, but we should check obviously here.
Oh yeah, we can break on the first true, and that should be the largest.
Should it be though?
Because we might get 999 and maybe like 500 is one, but then 998 plus times 998, as far as we know, might be a palindrome, and we missed that because we kept one.
Stopped at the first one, right?
Yeah.
I don't know why. What's the?
Oh, what if one true, we break into we break the J loop and move back into the I loop, and try it. So we compare all the different values for the highest. So
well, I mean that'd be an interesting way to improve performance, perhaps. But let's just try and get the right answer first.
Before we go on, I want to take a second.
Sure.
I believe, forgive me if I'm mispronouncing your name, Tasif Qureshi. He joined. Welcome, Tasif.
Hey.
If you want to say hi or jump in and contribute or anything like that, feel free. Correct me on my spelling or pronunciation.
No, quiet.
They may not realize they're muted.
They may not, or maybe they're just quiet type. It's fine.
That's fine.
Both are fine.
All are welcome.
Glad to have you, man.
So as we continue, we need to see if it's the largest. So obviously we're storing the largest. So if this is, or I don't want to do that.
Freedom.
No, I don't.
I love ternaries though.
Oh, I'm going to use a ternary, just not there. I don't want to write that whole. I don't want to do his palindrome function twice. Largest equals, oops, n is greater than largest. Return n.
But n is a Boolean.
Yeah, I was just about.
Is it?
Yes, because
it's palindrome. It returns a bool.
Yes, it is. We're not actually getting the largest, are we? We have to do I times j. There we go. Good catch. Oh, question mark.
Can we change the multiplication?
J.
We might.
And largest. All right. So that's what my initial thought was.
Can we cache the multiplication?
Is that multiplication that much of an improvement?
No, it's not. Bard hey equals I times j.
And
R and the N and the.
But we only want to do this R question if N equals true, correct?
Yeah, this is very true. So we don't even need n necessarily. We just got to see if this is true.
Mhm.
Oops. If n is true, then we do stuff. Because if it's not true, then we don't really care about that result.
Can I ask that you move the far r out to the above end and this calendar?
Yeah, we can do that.
I'm so stickler.
He is. He did my pull requests forever, and it's a known thing that he is a
Please
stickler.
run the formatter, James.
There you go. Okay, so again, let's see, and so let's look at that. So we're going through each I, and then we're spitting them out. So what we can do also, actually, I'm going to put that back. Let's just console log here what our values are. I think that'd be pretty cool, so we can see what we're looking at. So if we do I, if I can get my J, and then we'll just look at those. Oh, actually, we'll do the multiplication too, I guess. R. All right, so let's check this out. So we know this is working. Problem 4. And let's run it.
Did it save?
Of course. True. Of course not. And let's run it. I think I hit save after I hit the console command.
Oof.
Ooh-wee. That
Well,
is
we
a
did
lot
find
of
every
values.
palindrome.
We did. Look at that. Those are beautiful.
Dang, son.
But we didn't actually return what the largest was. You know, silly us. So let's
One thing is that I'm noticing. Can I? I don't know if you're building up to this, and I'm skipping ahead. Do you mind if I?
No, go ahead. Yeah, it's the more input, the better.
Shouldn't we be returning a tuple?
That's if you want. Like, what would you return if it's not a palindrome?
Well, because we have to find the 2 digits, right?
No,
We just have to find the largest
the
product.
product. Yeah, we're solving for the product. Yeah.
So we don't need to keep track of I and J. We just need to keep track of the
multiplication
of them.
Exactly. And then the largest is largest. All right, cool.
So I'm trying to think because
Thinking is hard.
well, what was pointed out earlier was that we might be skipping over values because of how we're looping.
Well, in this case, we're not because he had stated that if we do a break, or if we just assume the first one is the largest. So let's go back and look. We can look at the log and see. Like here, so we take this one. 27 is bigger. At any point, is there a larger one? 25.
So you think we have to brute force it?
In theory, I think so.
Yeah, what I was suggesting was just an
72.
efficiency thing. Like
Yeah.
if we find that 999 times 907 was made a palindrome, we don't need to check 999 times 906 times 905 times 904. That's all I was adding in.
Yeah, well, there's a lot of numbers to really compare in my head, so let's just run it and see what we get. All right, lots of stuff. So 906, 609. So I wonder if that's even up there.
You can copy all that and oh yeah.
It's not even in the list.
It's not?
I was going to say you'd have to scroll D near the very top because it's likely we found it at the beginning.
How can it not be in the list?
How can we because it's too much for the console to keep track of.
Oh.
So
I want to do it only when we replace largest. If largest equals R.
Anyway.
So let's just do that. There we go. So the first one we found, or the first largest we found, like Benjamin had said, was 995 something else, but the actual largest was the next replacement, which is 993 and 913.
So why don't we? Here's an idea.
I noticed it never found 583,995.
Because it never reached that point. Well, it never.
Because
It
because
probably
this
did.
one is not bigger than this one. Once this one
Oh,
became the
thank you.
largest, yeah.
Thank you. That's all I was missing.
Yeah.
Why don't we say that's I greater than 899?
I greater
J-
than
J
899.
greater than 899 because it's almost guaranteed that these are going to be the two correct ones are going to be in the 900s, right?
Is it guaranteed? I mean, we know now because we see it, but
Right.
what if both were 899? That was the palindrome. Like we don't know for sure.
Well, we just ran it and we found out.
Well, now we know, and we can just say what I equals 993 and
We use
this equals
scientific.
9913, and boom, I got the most efficient one there is.
Oh, return 993 times that.
All right, so let's put this in 906 609. Let's see here. 906 609.
Watch, it turns out we're wrong.
Oh, if it hasn't said we're wrong, we're usually right. The answering yes is a very dramatic pause.
Nice.
Cool.
We are the
One down. Yeah, I saw that.
486,000.
Let me go back. Oh, we missed it. 400,000 something.
486,609. See, right there, the 608. We're 609. Next to solved by, the solved by column. Right where your mouse cursor is.
Yep.
Or where my mouse cursor is, actually.
All right, so let's go on to the next one. We got bunches to do if we can.
Yeah.
So smallest multiple. 2520 is the smallest number that can be divided by each of the numbers 1 through 10 without any remainder. It's the smallest number that is evenly divisible by all the numbers from 1 to 20. Okay.
Does it end with a 0?
I would maybe. I mean, if it has a 10 in it and a 20, so it has to end in 0.
Yeah. So we can go by tens in our counting, right?
Yeah, that would be a good way to definitely make it a little bit faster. Let's see, problem 5. All right, so we got to get all the numbers between 1 and 20. 1 through 20. And we're gonna basically iterate. This seems pretty straightforward. And I equals what? 1. It's obviously not 0. No, I don't think this will work. I think we got to do a while loop.
What's the other requirement? Can we put the other smallest positive number that is evenly divisible?
Yeah, so basically no remainder when you do a modular.
All right.
Is there a way of expanding 1 through 10 to create 2520?
Yes.
Without following the same requirement.
Shall we do the whiteboard?
I'd like that.
All right, so what was the number again? 2520?
2520.
2520, people. All right. So this is easily 10 and 252. All right, so 10's included there, so that's good. And this is 2 and
136.
36, yep.
Or 126.
Oh, 126, yeah. All right, and then this guy is 63 and another 2. So, which means this could be. Let's scratch this. Let's go here. Alternate. 4.
All right, you want to make it easy proof.
And 63. Right?
Okay.
Just so we want to have a 4 in there, guaranteed. So this is what, 9 and
7.
7. That's prime. This
And
is
those
3s.
are 3s. Yep.
All right, so we got 1's guaranteed to be in there. 2. This is 5 and 2. So we have 1, we have 2, 3,
3,
4, 5.
6 by the 2 and the 3.
Yep. So 6 is implied.
Mm-hmm.
7, 8 is the 4 and the 2. And then 9, and then 10 is up here.
So you're skipping the non-primes.
I'm not skipping them. I'm just they're implied because
Well,
the two.
Because we have to multiply all these together to get the number, right?
This is
No.
math stuff.
Oh
No.
wait, we're not skipping 4. 4's a.
So hold up. How many
We're not-
2s do we have?
So we're not skipping numbers. By having certain numbers, you're also implying other numbers. So if you have 8, you're implying 4 and 2, or 2, 2 and 2, right? So by that implication, it still fits in the criteria of does it fit evenly into 2520?
Yeah. Well, because what I'm thinking of, and this is sort of it looks like a reverse way of doing it. So I think you already know what I'm getting at, but like basically trying to do 1 times 2 times 3 times 4 times 5, etc. until we like.
Yeah. No. Well, I mean, we can take a look at that and what that could possibly even be. I mean, but even if we looked at it that way, so say we did do 20, all right? Did a countdown. So this implies what? This implies 5, 4, 2, and that's good. So then we have 19, that's
So-
prime.
So I was about to get to this, but yeah, all non-prime numbers can be broken down to multiples of prime numbers.
Right.
And
That's
so
unproven.
Hmm?
That's unproven.
Is it unproven?
Arbitrarily large even numbers, that is unproven.
did not know that.
Arbitrarily large.
I happen to know that fact about math.
I did not know
9,
that.
2,
Though I do not
6,
believe we are dealing with an arbitrarily large number. It is
17,
even though, I will not deny that.
16.
Yeah,
We're implying
I'm
8,
gonna have to look this up so I can
2, 4,
prove that I'm not talking.
15 is 5 and 3. So basically we go through here and sort of multiply in the numbers that would work. 14, 13, 12, 11, 10. I think at this point we've got them all probably. 12 is 6 and 2, 7 and 2. So this is a guaranteed 7 here, 14. So gotta have that one. Gotta have this, gotta have this. 13, 11. We don't need 10 because that's implied. 5, 2, and 4. So the easiest way to get 5, 2, and 4 implied is the 12, 15, and 16.
So by multiplying.
Nope, we don't need to do that.
So by multiplying all the primes of that we can drive.
If we do 20, how can we guarantee 9? Can we guarantee 9 right now?
3, 4.
2 3s.
2 3s. Is there any?
The 18.
Oh yeah. 18.
But that also gives us an extra 2, an extra 6, and an extra 3. Remember, we want the smallest number.
We're doing 1 through 20, so 9's already there.
So
Right.
9.
But
Okay, so
we
we
do-
can just add 9. So if we did,
2 5.
just out of curiosity, we could just throw these numbers together and see if it's right, and then that'd be cool. But we can then programmatically do it. So 20 times 19 times 17
I
times
feel like we're gonna very quickly blow past our.
14 times 13
4.
times 11 times 9. That number's huge. I can guarantee that's not the right answer.
Yeah.
Yep.
Yeah, there has to be a smaller number. So
How are they deriving it in the first place?
So-
for 1 through 10.
Yeah, that's why I was
programmatically?
looking at myself. So splitting up the number in the 1 through 10, I saw there were 3 2s, 3 3s, and a 5. So those through the multiplication of primes were able to create every other number. And that's why I'm working on mentally right now. I'm using scratch paper, but I'm not finding anything yet.
Yep.
3
I bet
2s,
you-
3 3
I-
5.
I'd wager. Yeah, so there's 1 5 here. So 5. that one. 1, 2, 3, 4, 5. So here's 5. 1, 2.
I missed the 7. There's a 7 in there as well.
Oh, we skipped the that block entirely. The second block.
Oh, sorry, this is completely out.
Yeah.
This was split up in the 4 and 6 and 3. So this is actually 2 2s.
1 5, 3 2s.
So 3 2s. Oops.
And 2 3s, and 1 7.
Yeah. 1 5, 1 2 3 2s. 7 3 3. Yeah.
Times 2 times 2 times.
Oh, is there only 2 3s?
Yeah, it's only 2 3s.
Okay.
But yeah, so
That makes my math a lot easier. That all makes sense.
all right, going through while you do that, let's see if this programming method is faster. So
Fair enough. The programming method's probably faster.
I equals
Oh, 360 times 7 is 2520.
2520. You want to do
Yep.
that? You want to try it?
No, it's not. It's not. No. I'm saying that our prime math.
Oh, well, yeah, obviously we knew that.
I know. I'm just always amazed.
The math works. Yeah, when math told the truth.
Oh my god.
That's a
I feel so
while
smart.
loop. So
14 is
I is less. Actually, while what am I doing? I equals 0. Nope, we'll do 1. What am I checking for? I'm just gonna check for true. That's fine. All right. So I'm gonna just modular each. Number. Wow, what's a nice way of doing this? I'm gonna do the ugly way first. So
I'm out of my depth on doing math stuff, so I'm gonna step away and.
So I did figure out the answer just through mathematical proof, but I'd love to see how we do it in programmatical proof.
Can you wait till I get back, Benjamin?
Of course.
Thank you.
Guys, I want to see the programmatical proof.
Yes. So we're going to iterate through this loop of 1 through 20. And we're going to increment. We have to increment I. Actually, let's start with I is 0. And we'll increment I at the get-go. So we'll say if what number are we at? I mod j is equal to 0, then we know this is divisible by that evenly. So this is a true, else we'll do some sort of false. All right, so let's sort of think here. Oh, there's a button for this. There we go. All right.
So we need to get 20 trues, basically, for this to all be true?
Yes.
All right. Could we have a value that's like a total or something like that?
A total. Well, we just need to make sure we don't get one false. Once we get one false, we can break.
That's a lot easier. That's a good point.
So while true, so let's just do an intermediate Boolean here just for giggles here. Var tester equals, and we'll assume true here. So that way when it's false, we'll know just to stop. And we'll just keep it here also. So we'll know to stop if we have to. So this is tester, it'll remain true, and then this will be, tester will be false.
As long as we reset tester as true in the while loop, I don't think we really need to worry about it in the for loop.
But in the for loop, we want to stop because we don't want to keep doing the test.
We want to keep the tester equals false, but I think the tester equals true is an unnecessary loop because it already is true and we're just resetting it to true. The moment it's false, we're breaking out anyways.
Right, but we're also iterating every number. So we have to start over our total. Because, so say, for example, we're starting with 100. We're checking each 1, 2, and then until it's false. And then we start over, and then we go to 101, we have to check them all again.
Yeah, I understand that. I'm just saying the tester equals true inside the if statement at the very end
Oh,
is
yeah, yeah.
unnecessary. That's all I was saying.
Oh, I got you.
And this is an efficiency thing, which I'm probably not what you're worrying about right now.
Yeah. So right now, so what I did is I just made this visually understandable. So then I just for those watching later can watch the update.
Build one to throw
Right.
away, as they say.
See, so if I just start with this might be a little harder for someone to understand what's actually happening. But now that I've sort of condensed it, so before they can see the before and after and sort of understand that this is going to essentially provide the same response.
Can I, this isn't an efficiency thing at all. This is just a programming quirk thing.
Tell me more.
You could combine your var tester into your for loop so that var j equals 1 comma var tester equals I modular j equals 0. And then you can technically have an empty for loop.
That sounds hilarious. I won't torture them with that. So let's see. So this is while true. So if tester is still true, then we can break, right?
Yep.
Or let's just console log. Yeah, let's just CW. Let's just return I. Let's console log I, and then we'll just return the stop. That sound fair?
Yeah. I was just about to say this is a void method, so maybe yeah. Okay.
Yeah.
So you can only return nothing for void.
Yes.
So
but essentially I just want the while loop to stop because
yeah,
this is
basically. No,
yeah.
Everything's good. Everything's good. I just
Wonderful. All right, so let's do .NET Run. Let's do it. What do we get? What's your number?
So I don't have a calculator. I just have the primes of all of them combined. So if you can multiply them
man.
together, I'm sorry, I don't have a calculator on me right now.
What is
Probably
it?
not the smartest thing. So it's
Oh my God.
4 2s combined together. Then there's
So
2
16
3s.
times 16.
So actually, we could just start with the 2520, and then I multiplied 16. Or sorry, so it was 2520. Then I multiplied 11, 13, 17, 19, and an additional 2.
13.
So ignore the 16s. The 16s were me just scrambling in my mouth. My apologies.
It didn't click.
So
There we go.
you multiply
2520
Times 11.
Okay.
Times 13.
Okay.
Times a 2. Times a 17. Times a 19.
so all the primes.
Yeah. So
Hey,
all the
look at
primes
that.
and the 2 was added in there because I needed
You gotta get to 20.
Hmm?
Because you had to get to 20.
actually that was so I could get to 16. So
Oh,
all the
right.
primes, if you look at all the primes separated, so back in 2520, it's 3 2s, 2 3s, a 5, and a 7. So
Right.
like you can make a 4 out of 2 2s. You need the
Yeah.
third 2 to make an 8. So we
Right.
needed a fourth 2 to make a 16. You need
Right.
2 3s to make a 9. That was
Right.
You got 12, 14,
Cool.
15, 16, 18.
so yeah, like 12 I was able to make with
3.
2 2s and a 3. 18 I was able to make with a 2 and 2 3s.
So these don't need to be in there at the same. These don't need to be like extra. Like they aren't consumed by.
Correct. Yeah, we're not just dividing until we get to 0. It's just you use the original number and do a modular.
Why does it work if you can imply their existence without consuming their existence?
So that's like saying if 20 is divisible by 5 and 4, it's also still divisible by 2.
Oh, because they're mutual invariance.
Yeah. Yeah. So you're essentially just mathematically it's just a proof of in a different form. But let's see. So this obviously looks right because the program did it, and then we got primes go over here doing it. Call you Benjamin Prime, and let's see. Where is my answer check? Control V. Ooh, let's ditch the
Are they
comments.
gonna? Do they accept comments?
I don't know.
Can we try?
I suppose.
Now is the time to try.
Nope. Or our problem was wrong. I told you they when it's wrong they're real quick about it.
Oh,
I
Ah.
think we got it.
No, they said I can't submit for another 30 seconds. See what happens when you get
Oh.
something wrong?
dang it.
Uh,
Okay, given the state of this number, I don't think we're going to be able to brute force it.
Yeah, I don't think they let you brute force it because of this.
Obviously.
they try to make sure it's big. The problems are big enough that you can't, or at least that's what I've noticed.
Yeah, for sure.
By the way, a lot of this prime stuff, I actually.
Oh no.
Come
Oh
on.
my gosh.
You
I
got
was,
kept.
I was too quick. 1, 4, 8, 8, 3.
Is that a 1 or an I?
That's a 1. I'm gonna say 1.
Play audio.
I'm gonna say 1, and I still have to wait another 15 or so seconds, I think. Let's look at the. I can't look at the next problem because then I'll leave the page. All right, we're going for it. All right, it's not a quick no. Looks like we're getting to get it right.
Ugh,
Good job with your prime, sir.
thank you.
It's funny that I know the reason why it's taking so long, and it has nothing to do with the actual comparison and everything to do with the fact that it has to update the database.
Right.
Yep.
Yeah, exactly.
I was just about to say, all you have to do is this equal to answer dot zero? Answer
It's
zero.
like, all right, well, we inserted your answer, and now we have to give you the index of that answer, and therefore give you a number back. This is why it's taking forever.
Yep.
All right, so off to the next problem.
Oh God.
The sum of squares of the first 10 natural numbers is that thing. The square of the sum of the first 10 natural numbers is an even larger number.
I'm so glad they
There's
give
some-
you a visual of what it looks like in math, because I would have not
Yeah.
understood it otherwise.
All right, so we're looking for that difference. I think what's the difference between the sum of the squares of the first 100 natural numbers and the square of the sum? Okay, so that's just seems like a pretty straightforward math problem. I think we can breeze through that pretty quick. What's time check, Sir Zach?
About 7.
Oh, cool.
We got a
Plenty
little-
of time. We're breezing.
We can. We don't have to stop right at 8 o'clock. We can keep going if we're on the roll here. But 2 hours is just kind of like a general cutoff.
Yeah.
We don't have. We didn't have any secondary segments lined up, right? Like we were doing.
No, there's no designer for the questions. I mean, we could be open for, interview question,
Yeah.
suggestions or stuff like that, but we'll stick to this for now.
Yeah.
So we're looking at the sum of first 100 natural numbers. Okay. So let's make an array here.
Right.
Let's see. How do I want to make an array?
Wouldn't you just want to have 2 variables? You have an I and a J, and then you have a K that increments to 100.
I have a quick question.
No,
Sure.
not like that.
With how large these numbers get, is there ever an issue that the numbers given to us by Project Euler will not fit within an integer, give its bounds and like 4 billion?
That is very common, actually. Yeah.
Really?
Yeah, very
You can
common.
pull up an N32,
Oh yeah, that's why you have to switch to a long. Definitely.
but that's like 2 billion.
Yeah, well, some of those primes you have to multiply the first 50 primes.
Yeah,
And
like
it's like,
if you ever have like 4,000 factorial, that already broke it several times over. Like,
Yeah.
Yes.
I mean, just going back to the primes, the list of primes,
they had to check 999 times 999.
it's just a
And that-
large number.
Is that capital L? Is that the literal for long?
Yeah, you would do var long L equals 200L, and that would imply the long,
Okay.
which is essentially a N64.
So, what I was gonna recommend is you would start off with var I equals 1 and var j equals 1.
Uh-huh.
And you just loop to 100. For k equals 2, and then you can do the individual operation. So for you do I equals I plus k times k square k. And then you would do j equals j plus k. And then you would do I minus j squared j equals.
You
Actually, no,
totally
it would be
lost
j
me.
squared. It wouldn't be j squared j, it'd be j squared 2. And it
Totally
would be
lost me.
k
All right.
squared 2.
All right, walk me through it.
All right, so var equal or long I equals is 0.
Dang it.
While we
Alright.
walk through it, I'm going to be back. I need to take a quick break.
Let's do it.
Sure. Long j equals 0. And then for long k equals, or so actually it would be short. You could do a short. So you do a for loop. No, the k is in the for loop.
Okay, got it. Let's just keep it simple.
Sure. For int k equals 0, k equals 2, actually.
2, okay.
K is
Well,
less
k
than
is less
101.
than 100.
Less than 101.
101, okay.
And then k plus plus. Because it has to include
Sure.
100, right?
Yes, I believe. Let's double check. First 100 natural numbers, so yeah.
Okay.
Yeah.
So then inside that, I equals I plus k squared 2. So k times 2. There's two multiplication symbols. And then j, maybe it's going to force you to make.
Times 2. What are you trying to accomplish there?
I'm trying to square k.
Oh, well, just k times k.
No, because you have to square it times 2. K times k is going to be a hell of a lot. Like when you're going to do 101 times 100. Oh, you're right. Duh, math, of course. And then j equals j plus k.
Okay.
And then at the bottom, after the loop, you can write out I minus j times j.
So I minus j times k.
J times j.
J times j. Oh, muff that up. There we go. All right. Pretty snazzy way of doing it.
That should work.
Pretty snazzy. Oh, I suppose I should change the problem 6.
So I just came back in time to see the end result.
Welcome back. So this very quick number here, we'll see what is a negative number. So we have to flip it.
May I ask why k is starting at 2 instead of 1? And
Because 1 squared is 1.
but we still have to apply it.
Yeah. So I and j have to start at 1.
I and j have to start. No, well, j has to start at 2, right? Because it's 1 plus.
No, because it's the sum of all the natural numbers.
Okay.
So it's the 1, and then we add 2 to it.
Okay.
Do we need to? Well, the k times k should run it first, right?
So that's the answer that we got from this. Shall we try it?
Let's see.
I think we shall.
I just came back. Once we added that 1, it all. Well, I guess because they're subtracting from me. No, wait. J is multiplied. Yeah, everything seems good from my side. But.
Woohoo!
Very nice.
In math.
Very nice. Very nice. All right. So what we're accomplishing here is we're just, for every number as we iterate up. So when k equals 3, we're taking, this is the, so if we do this, This is the sum of squares. This is the just the sum, right?
Sum of naturals.
Yeah, let's do that. Sum of nats.
Also, it is worth noting that it's in the right line code that we square the sum of nats. So
what's the? I gotta find. I'm gonna look at the actual notation for squaring something.
R square.
Assuming
sum
it's not
of
just
nats equal nates. Sorry, Nate. Sum of nats times sum of nats. So then we can do this, just so we can
make it easier to read is all.
see it easier for sure, for sure. All right.
Nice.
Very cool. So my initial thought when I was first looking at this, I was just I'm gonna make a function that just gives me the sum of the squares. I'll make another function that gives me the sum or the square of the sums, and just compare those numbers and just iterate until I find the value I want. But yeah, this is definitely goes through with the iteration one time. So definitely half the speed it takes to do this than it would have done mine, because I would have gone through 1 to 100 2 times to get all those numbers.
But and that was actually a question I was about to ask. Is that any more efficient? Because it's, while you're doing only one loop, you're doing twice the work in that one loop. So
well, you think let's
loops are more expensive than
okay,
because you have to do
think of it this
yeah.
For me to loop over.
Oh, so the loop itself has a cost. Okay, that's all I was asking.
It has a fairly significant cost, especially compared to multiplication.
Okay, that's all I was asking.
Definitely.
Thank you.
For sure.
Because we are fortunate in that both loops have the same distance. So
yeah.
Well, it's not just that. It's also the fact that like basically all of computing is built around like multiplication and addition, stuff like that, with like nands and zors and ors and all that. The logical gates that underpin computing. So those operations are always going to be speedy compared to anything else you do, because everything else is basically a derivation of those operations.
Oh, does that mean that like ifs and else ifs aren't very expensive, or because those are ands and nans, or
no?
Am I misunderstanding?
Well, that's a complicated question.
Maybe not for today.
Well, I'll say this. In JavaScript, you generally don't want to have a lot of branches, because that creates runtime overhead in your virtual machine, where it's going to have to
it turns to runtime instead of
Yeah. So generally speaking, you shouldn't try to limit as many of your if statements as possible for performance reasons. But that's
so it's a balance between runtime and efficiency sort of stuff. Okay.
Yeah, I mean the other school of thought is that whatever's the most readable is the best. So if a switch statement or a series of if statements, if else's, is the best way to do it, then you should do it that way, like the most readable way to do it, because maintainability has its own costs relative to performance.
And that just kind of depends on what sort of program you're working on.
Yeah,
you're going to have to reuse it a lot and modulate its readability as a perhaps more efficient.
Yeah, it's a game of doing as little work as possible, and so knowing that for loops have their own costs with regards to like bounce checks and things of that nature, you would want to do the multiplications at the same place versus splitting them into different loops.
All right, thank you.
For sure. Very good. Thank you, Zach. So that being said, let's go on to the next one, because those two were fairly easy, I would say. Let's see. Oh, here we're back to primes. So by listing the first 6 primes, we get that. So we can get the 6th prime as 13. What is a 10,001st prime? So this iterates back to this Project Euler reiterating concepts and that you've done in previous problems. So I'm just going to go ahead and scroll up and look at my prime stuff, because I know we were going to eventually use it. So here I have this, get primes under. All right, so basically I'm saying get all the primes below a certain number, but that's not what we need here. We need a certain number of primes. So let's grab this guy and make a different one. using the same concept.
My cat decided to join us. He wanted to help out with the program.
Get prime.
I hope your cat's good with math.
He's the best.
I'm
Yeah,
impressed.
He has a degree
Thanks.
as well. He's working on his PhD right now. You should see his thesis within the next year.
So, all right. So we got index here that we're going to be providing, and we want just the the last one, right? So we're just going to return a long get prime at index. All right, cool. So we got a list of primes, and then we can just while primes dot count is less than index. That should work. All right, so then we just return index, right?
Yep.
So let's see. So you can see all this little stuff here that we found. We were figuring stuff out. I was like, I forgot to increment Q, and that was a pretty tragic bug. We would sit there and watch it run, and like Q was never incrementing. We're like, what is going on? And it was quite amusing, and in hindsight, of course. But all right, so we got some get prime at index. So let's just go ahead and toss this in. Problem 7. Get prime at index 10,001. And then we just console write that prime. Fair? No complaints?
Yeah, so before this thing started, I decided to try a few of these on my own. So 1, 2,
Nice.
and 7 were the ones I tried, and
2 and
the
7.
only
Okay.
I just jumped to 7 because 1 and 2 were just fun but really quick.
Yeah.
And oh, sorry, I got an interruption.
Sure. So let's see. 10,000 first prime. We got problem 7. Console writing prime at index 10,001.
Wait. Wouldn't it actually be at index 10,000?
Sorry about that. But yeah, I did need to Google some stuff for 7 because I skipped 3.
Ha, yeah. So that's a good point, Zach. I need to do -1 on here.
And I needed like 10 minutes just reading what I Googled so I can understand. So I didn't want to steal the answer. I want to understand the answer.
Of course.
I think you could just do primes.last.
Yeah, but that's using link.
Okay.
And I mean, this is technically also using link. But we can do that. Let's just do that. We're already using it. All right, let's run it and see. Let us see. 104,743. Is that what you got?
That I don't have that with me right now. I apologize.
104,743. Check it. Nice. Another easy one, man. We're breezing to it. Too easy.
Yeah, I will say that one isn't easy, but when you've done 3 already, it becomes a lot easier.
Yeah. So prime was there. Was that the only prime we did?
So far.
Yeah, so this is our second prime. There's more primes down here somewhere, I'm sure.
Yep. All right, number 10, summation of primes.
There you go. See, it's just all right. Greatest product in this 100,000 digit number. Okay. So I guess we got to copy paste this. All right, so that's interesting.
What does 64 go up to?
What does 60? Oh, the max number.
Yeah. I suppose you could just print it out. Huh?
Yeah,
One dot max value.
N64 dot max value.
Whew.
Yeah, just for comparison's sake.
Yep.
Yeah, significantly larger. So this is 2 trillion,
2
so
billion.
2 billion, 2.1 billion, and then this is 3, some number I don't know. It's beyond trillion, so therefore I don't know what it is.
I think most people are there. I think after trillion is quadrillion, and I don't know the number
There
after
you go.
that.
Yeah. Decamillion. I don't know. Pentamillion.
Septimil. Oh, it will just be.
I just know it's a really big number. More pennies than I'll ever have. So let's see. Let's do problem 8. And then we have this big number. Copy this again. Var number data equals. I'm not even going to use a long because that's not going to work.
I was saying, dude, is there like an int 28?
It's going to be an int 500 if it's going to be anything.
I'm looking up the.
No, the definitely the best way to do this would be to split this up like this. There's no doubt. But the idea is that we have to multiply 4 characters, multiply 4 characters and any 4 combinations of these 4 characters to try and make the largest number possible, right? Yeah, greatest product.
Well,
okay.
that was the example they gave. It's asking us to do it with 13 digits.
Well, yes,
Sorry.
what they're asking for is correct. Yeah, they're asking for the 13-digit largest, but let's try and find the 1,000.
Yeah, because if we can find
have
4.
a comparison. Yeah, for sure.
Yeah.
Good, a good test func to see if our even logic.
Just don't want us checking it correct and going through the whole
30-second wait. Yeah.
Yep.
All right, so let's see. Well, let's just do what's the number I want? Let's just call it K equals.
Is this a needle in a haystack problem?
No, this is a iterate till you're done problem.
Damn it.
That,
I think this could be done semi-efficiently because you could actually split this up into anything that has a 0.
yeah.
And basically only iterate through numbers that are that don't have that 0 included.
Yeah.
Oh, now it's a needle in a haystack problem.
So yeah, but it would be tricky because you would iterate over zeros. But in this case, you have to ignore the 1 completely, right? And so these 4 digits work.
Yeah.
So from here it would move on until we get to this 0. I mean,
Yeah.
you could really nail this down and really get high performance on this if you.
I can already see where the 4 digits are going to be, but that's just because I got lucky and saw it like a needle in the haystack. Yeah, there's
Nice.
over to the right. There's a 9989. So
nice.
hard pressed to beat that.
It's 13 digits though.
Yeah, once we get to 13 digits, that has a bunch of zeros around it, so that's not going to happen.
Yeah.
So we are finding a new needle.
Yeah. So we know where this one's going to be. But we don't
Oh, you know what? I just thought of a really efficient way to do this.
Well, I think for starters, let's just do it in the sense of maybe we did want to split characters.
Yeah.
Right? So we know. So if we split them up, if there is a chunk of numbers that doesn't have 13 characters in it, we already know that whole array is junk, right?
Uh-huh.
So if that, and we only have to, and if there is 13, then we only have to do one multiplication for that whole block of text. So that'll definitely save a lot of time in terms of trying to multiply every character next to each other.
So we would do var entries equals data dot splits character 0.
Yeah.
Dot where x to x dot length is greater than 0, or equal to greater than or equal to 13.
Sure.
Because yeah, if the length is less than 13.
Whoa, that's a minus. So using link here to make things look nice.
Should we do, or should it just be x dot length equals 13?
No, because if it's greater, then there's more than one to test, right?
Because they only set the requirement was 13.
Yes, but if you have a block of numbers that are 15 strings long, then there's 3 checks there to do.
Yep.
And then
so then we'll have to iterate. Well, let's iterate through
well, I think
each.
you do it all in link.
Well, you could, yeah, that's true. Let's go ahead and do that.
Can I just like sorry to interrupt? I have something in mind, like a thought in mind that came to me.
Sure.
Like if like what we can do is split the whole like array in like 13, like in terms of 13 parts, like which one string that would have 13 like digits, and the string which has the least number of zeros in it would have the highest product in it, right?
If we were looking for specific products, that would be the true. But for this particular problem, we're looking for any combination of 13 characters. So this is 13 characters here, right? But
yeah.
This is also 13 characters. So we can't necessarily split at the 13 character mark because there is going to be overlap. Does that make sense?
Yep. Yeah.
Like here, so this is 13 characters here, and that's going to be our first entry in the array. And then we'll split out that 0. But then if we go 5, 10, 11, 12, 13, that's 113. But we don't have another 0 till here. So there's at least 15 comparisons here that we're going to have to check just for this one.
Yeah. So
and this one is garbage.
Each like thing can be like adjacent to one another. It
Yes.
doesn't like have to be here.
Yes. So they answer their example said that the greatest product of 4-digit number is 9989, which is here, right? And it's not necessarily that these were all split up into 4s. It's just that those 4 numbers were adjacent, and therefore the product of those numbers happens to be the largest out of all of them possible.
Okay, for sure. Yeah.
Cool. Thank you. All right. So looking at the entries, you wanted to use link to sort of
So the
continue
next
on.
would be dot select.
Okay. So let's do this in a format that I prefer to see. All right.
So now the easy case is x dot length equals 13, so we can just return x. Or we return we can just return x.
Because that'll be the largest of that group, right?
Yeah, but the problem comes in when because what I'm thinking we would want to do in here is figure out which of the which of the substrings, because we have to do say we have a substring of 14, substring of 15, substring of 16. So the first 13 might not be the largest. So we can't just do a naive x dot substring 0, 13 or whatever.
Right.
So we would have to brute force that string.
Yes.
So now we do actually want to select into numbers now. So x needs to be return x dot split dot reduce.
Okay. So not this one. Well, do we want to return x, or do we want to return just the answer?
Because we're going to return x converted to a number, and then below that we're going to do a dot max.
Okay, so we still have to return it to an, okay, we still have to convert it to a number then. So at this point, we're still just returning arrays.
Correct.
Sure.
Okay.
But we have to do comparisons with the lower numbers. With the we do have to convert x on length greater than 13 to numbers to figure out the products.
Yeah, but so if we at this point we just want an array of 13 characters, right, or 13 numbers, right?
Yeah.
So 1 through 13 there, and we want an array. Basically, it's an array of array, right? Because we have multiple sets.
Oh, so you want to
This is like 2, 3.
You want
14.
to return lists and then select many off those lists. So we can do a list of lists for x. And then select many to pull the product out.
Yeah.
Question.
Yeah, go ahead.
For the making the list of lists, I'm thinking of an efficiency theme. If we just limit the array to the 13 characters, could we overwrite? So like when we get to the next one, we overwrite the first character with a new character, then we overwrite the second character with a new character as we go in, because it's cutting the ones out to the left and adding the ones to the right, since order does not matter too much? Or am I just trying to do something unnecessarily complicated?
I guess you can do var y.split on empty character, and then we have our first list already.
Right.
Mm-hmm.
So and then we do y.length.
I will say I'm like, my mind, I'm still on the side of brute forcing, so I'm glad to listen to how you guys do it efficiently.
Yeah,
so.
yeah. Well, I mean, it's not necessarily that it's necessarily efficient, just sometimes LINQ provides a more readable, I guess, more
Precisely.
The way we're doing it, we might actually end up having to duplicate operations, so that would be less efficient.
Yep.
But
yeah.
This is where you get into the readability, maintainability.
Right. So so essentially, I mean, it gets, but at the same time, LINQ can get overly complex and not be readable anymore. So we'll see how this starts looking, and then we might just, decide it's getting too
yeah.
crazy.
At some point, it might be like, oh, we should just drop down to a for loop or something like that.
Yeah, I mean, because at some point, these 13 blocks, there's only 1,000 comparisons, right? It's 1,000-digit character. It's not that many operations. Of course, we're not doing a $10 billion numbers, so it shouldn't be too bad. But even then, we've split it down. Even if we brute force from here, it'll be significantly faster than someone just doing all of them, because we've cut out a bunch of numbers.
So then above the if statement, we would do var y equals x dot split on empty character.
Let's do that. All right, so y, what's your character literal?
Can you do like card on empty or something?
Yeah.
Oh, you have to do string that empty.
String.empty, yeah. Okay, so then that'll be y, and then we return y, right?
Yeah.
Okay. Well, we know we return a
new array y.
Is it a new array y?
Because we're gonna have to return multiple results for the next one.
I forget how to.
Just do new and then the array brackets.
Oh, okay.
No, then the braces.
Then it's the braces, yeah.
Yeah.
Good job.
And then you can do new
Okay,
one.
so
You do put a 1 in there to make it so you can explicitly size it.
cool.
So
Nope,
now,
maybe not. It's okay. We'll just go. We'll do it the happy compiler way.
happy way. All right. So now.
All right. So now these are guaranteed to be bigger than. These
Now
are
we're going to return multiple lists inside this array.
right. Right. So in order to do that, we have to iterate through each possible split. So
we have x dot length, and so what we would do is x dot length greater than. Sorry, we would cache x dot length into a variable, and then we would decrement it until it reaches 13.
why?
So we can do we can pull all the substrings in one go. So 0 to 13, 2 to or 1 to 14, and then 2 to 15, etc., etc.
Okay.
So you can do substring.
I was thinking. Okay, let's go ahead and do that. So
var ret equals new array, and this is going to be we're going to have to actually type it now and give it a so new list string array.
it's array.
No, it's lists. Yeah, and then array after that, the brackets, and then there the length is going to be x dot length minus 13.
X dot length minus 13.
Oh, darn it! It has to be a constant. Frick.
Yes, it does.
All right, just do new list of string.
Yeah.
And then we can convert it to an array at the end.
Yeah, that's fine. All right.
And then has to be a.
Can we just?
Yeah, there you go. So
All right.
While and then var z equals x dot length. And then while z is greater than 13. Ret dot add
substring. X dot substring of. Is it
z minus 13?
Z minus 13?
Yeah.
We had someone just join in, by the way.
Welcome.
Z minus 1. The second parameter.
Oh, right. I'm sorry, I was looking at the screen here. Z minus 1. And what's the next?
Is
the length?
Oh, number.
Oh, that's 13. That's 13. Right? So it's start index and length.
Oh, really?
Yeah, so substring should be length. Substring and length. Start index and length.
That's different from JavaScript. JavaScript, it's start index, end index. That's what
Yeah. So, but still, this is a string.
How you guys doing?
Hello.
Hi.
Hello, James.
Hello.
Hello, Zach.
Hi, Jerry.
Split.
Long time no talk.
Empty.
Hi. It's good to see you.
All right. So why didn't this work?
Because it's a string array.
Oh yeah. How do I split it then?
Wait, no, then it's not. It's a new list of arrays.
Oh, there we go.
No. In your bar ret.
Okay. Is it?
Yeah.
If I remember correctly.
Yeah.
Okay, so add, and then I have to split this now. String dot in. Nope.
Because you keep using the uppercase string.
Oh, it's a habit, I guess.
Java mode. You and James, or not James, Joseph, you both do it that way.
So
So I think it's greater than 13. Is it greater than, no, greater than 12, right? Because we have to include 13 as well.
It's greater than 12.
Because we have to include index 0.
Oh,
So greater, or you can do greater than or equal to, I guess.
yes, it is greater than 12. So if this is 0, so it starts at 14, it iterates
We would do
to
14,
this,
we would do 13.
and then we have to subtract 1, right?
Minus, yeah.
So we get a return.
But we have to do z greater than 12, so we include 13. And then we can return.
No, we don't
Yeah.
need to include oh wait, do we do? You're right. Greater than or equal to.
So then we return z, or return ret dot to array.
Return ret dot to array. All right. Now we don't need this guy.
And now we do it.
So now we have so let's look at entries and say it's an IEnumerable of multi-string. Is that what we're expecting?
Yep. So now we do a select many.
Sweet.
I think it's a select.
Shall. Yeah, it is. All right. So now we're looking at what is x. X is going to be a string of array of arrays.
X dot length equals 0. Or 1, I mean. Then we just return x index 0.
Say that again.
If it's x dot length is 1, then we just need to return x of 0.
If x dot length. Then we need to return
Index 0.
index 0, which will be
Just the one array.
the one array.
Otherwise, we need to now we would need to figure out
We have to.
the largest one.
Then we may as well do the math here.
So x0 dot reduce or aggregate.
Aggregate.
Well, it's yz.
YZ.
Yeah, you have to do 2 parameters.
Oh, 2 parameters. Yeah.
And it'd be it's multiplication, right?
Yep.
So, but we have to convert each of the characters.
Yep. It's int 32 dot parse y times int 32 z.
What's it complaining about?
And converts a string number 30 times integer. Please convert type into string. What's it comparing? Oh, did I set a type up here?
I'm not sure.
Where to split? Where select?
I don't think it's typed yet. Try.
Yeah, it shouldn't be typed yet. So
just put a return 0 in the else block and see if that fixes it.
oh. No. Cannot does it convert into string?
Or is it implicitly assuming that you're gonna always return a string?
This is a string. This is a string.
Yeah. So you need to explicitly type it as int in the aggregate for the aggregate. No, not there. The generic.
Oh,
Oh my gosh.
we'd be better off just doing it the other way.
Then we have to select it. We have to select each of those into ints.
Why can't we just?
Convert it to a string?
Yeah. Why?
No, because then we'd have to unconvert it again.
But then we have the product, right? Because that's all we need.
Yeah. Oh no, we lost Jerry and we lost.
Yeah.
Remember his name? Steve.
Yeah. Let's see.
I would say do an x0.select y to int32.parseY, and then we can aggregate safely.
x0.select. Got it. What am I pulling? Q aggregate?
No. Just parse that because it's a character.
Oh. Is it? No, it's a string.
Yeah, but it's a single digit string.
Oh, yes. So then, and 32 dot parse Q.
All right.
All right, and then it's complaining about these guys. What do you got? What? These are probably already numbers, right? Yeah.
Yeah. You can just do y times z now.
Yeah. Y times z.
Now I would actually return a tuple.
Okay. What do you want to return? X0.
X0, comma x, then our aggregate.
Like so.
All right. And then now we need to
Figure out the largest. Why don't we make? Oh, I wish we could just make a function that just does this for us. Then it'd just be nice.
We could. We can make an inner function below the return statements that.
Oh man.
No, that'll do it.
Let's
I
see.
have to look at the syntax real quick.
Well, let's get this going. So
We're gonna need another.
So here,
we can do an inner query.
You don't want to just have an inner variable to compare.
I mean, a million different ways to do it. Benjamin, do you have any thoughts so far?
Honestly, I've been ever since we had that return y at the when we start. I understood splitting it apart. After that, we were talking about a lot of context that involves more thorough C# knowledge than I do than I know.
Yeah.
It's been kind of watching you guys manage with strings and nested variables. It feels like.
So this is where it's getting really complicated.
Yeah. So I haven't I understand what we're trying to do, and I understand how this splitting is assisting and making it make it more efficient. I don't know how I can input anything because I'm not sure how far we are in that process.
Yeah.
I'm not sure.
Right. If you want to compare, just this. If I can zoom out, how do I zoom out? Minus. Oh, there it is.
So
here's your problem, Zach. Right.
Yeah.
Yep. This one. I had
And
found.
we're still done.
Yeah, we're still not done.
Yeah, it seems like from what it sounds like, it seems like you guys have found the means to make the 13 distinct variables, and you still have to take those strings and churn them into integers and compare.
Correct.
So.
But we have to return. We have to. Do you know what a tuple is? Well, I mean, in math, you know what a tuple is, but in programming,
No, non-programming.
It's pretty much the same. The idea is that it's an n-numbered collection of items, and it can be any type of item.
Okay.
So
think of it as points on a graph. It's just a bunch of where x is one value and y is another.
Okay.
Yeah.
So
the reason why we need the tuple is so we have access to both. So we're going to find the max, but after we find the max, if all we do is return the aggregate, then we've consumed the string and we won't know what the answer is anymore.
Well, we will because we want the actual multiple. We want the product, right?
We want the product.
We want the product, not
the. Oh, then we don't need the tuple.
Right.
We don't need the array. We just need the.
Right. So then.
And then we don't even need the select many.
Don't we? But we still need to go through the inner array. So.
No, because we can go to the select and we can do return y.select.aggregate, and then then we can cut out our because I thought we needed the
actual string. No, it's a little simpler than that.
We can cut out this. Now we're actually a lot closer to being done then.
Well, all right. So then where do we go from here? So,
Well,
we
no.
go
So what
X.
we do is, I wish I could draw on your screen. We would cut that second select entirely. So take your dot selects inside that. Yeah, off of that X0. So take that. Okay.
Okay.
Cut that.
Cut.
And then your return new array Y.
Turn new array Y.
Low X dot length.
Here.
All right. So instead of returning the array, return Y dot aggregate. Or I guess you do, yeah.
Nope.
You probably need to do additional variables. There you go.
Okay.
Oh, where's your? You didn't You didn't include the
Split.
the select.
Oh.
To yeah.
Yes. And now I remember why we did that. Let's see.
Right, so that's that, and then now that we got your string array there in
That
the
one.
red, instead of returning red dot to array, now we need to do red dot max. And then inside of that, we need to do red dot max, and then you have your I don't know, Z variable, I guess, or Q, whatever.
M.
Sure. So M, and then M dot select parse dot aggregate. So that same exact, you could just paste that same exact thing in there.
All right.
There you go.
Okay.
And then get rid of that select there and just do a dot max. You're done.
Done.
Uh-oh.
That's- Wow. There we go.
So instead of return, now you can just do return data dot split, or write it out. That should.
Entry. Right?
That should do it.
All right.
Make sure to add problem 8 to main.
Yeah, that's not in there.
Oh yeah, it totally is.
Yo.
I said something useful.
Let's do.
Do you have any questions about this, Benjamin? Are you curious about any of the syntax?
I think I'm gonna have to. You said this is gonna be shown like on YouTube later or something.
Yeah,
Well,
yeah,
we're
it'll be
gonna
posted.
that, and we're gonna post the code on GitHub.
Yeah. So I think just having some time to read through that code on my own will assist me a lot.
For sure. So let's see.
Yeah, it should take a while because it's going through 1,000. Oh.
Oh. We blow
Exception.
overflow.
large.
So we
And,
need to fix
all right,
it.
well, there you go. So let's do int 64.
I like how it's either too large or too small. It doesn't say.
All right, we got a really big number. Let's give it a go.
Are we sure we got? Yeah, it looks like we got all the integers that we're multiplying together. We didn't multiply them because it's a 13-digit number.
Yeah, we
And
did. That's what the
We did. That's what the aggregate does right here.
okay,
It grabs each character and
Well-
and multiplies them together.
it's the answer is a 13-digit number, correct?
Yeah.
Yes.
Can you get?
No.
Is it
Oh no, it's 13 consecutive digits multiplied.
13. Yeah.
That's what I'm saying. We need the product of these 13 digits.
That's what we're doing.
That's what the aggregate does. That aggregate is essentially doing, say, a sum function, but we're multiplying.
I'm counting. So the final answer we have is 13 digits long.
That's coincidence.
That's what I'm saying is if you let's imagine all the numbers were just straight nines. I think that still doesn't give you a 13-digit number. I think that gives you a 12-digit number. Like if you 9 to the power of 13.
Well, hold on, James. Before we do any of that, I want to make sure that I didn't give you a bad link query. So instead,
Well, how about this? No, how about this? We just do 4.
Actually, we can prove it. Just so 987899799. Can we find that inside the large?
That's going to completely change the query's behavior.
Hold on.
It's actually going to blow up now.
So let's see.
So rather than the dot max where you do the selects, instead we want to do a ret.select dot max.
Ret.select.
And we have the same query inside the select, but then after that we put a max.
So I was just going through again. I was wrong about my assumption that it's going to be 12 digits or shorter. It is possible for our answer to be 13 digits as well and no larger.
Right.
So that instead of dot max would be dot select right there.
Okay.
And then get rid of the dot max there. And then at the end of the dot select, put a dot max.
Yep.
I don't know if that will change the answer at all.
Let's compare it to a forward character. That way we can more easily see if it's correct since we have that without actually. 9989. So we're actually returning the numbers. See that? That's crazy.
What?
That's what. So I was correct.
Yeah, strangely.
How's that? What?
Yes. Select parse 9 times 9.
So n is the aggregated number. Do we need to start it at 1? Do we need to provide a seed value of 1 for n in the aggregate? In order to, you know what I mean?
No, I haven't used aggregates in
So
very
after the func, do a
Uh-huh.
comma 1L.
after the func entirely.
Yeah, no, inside the parentheses after the func.
Oh, okay.
So the first parameter is the func. No, not that.
Sorry,
No,
sorry.
not there. After the n times z.
Oh,
By the way, I found the 13 digits in the 1,000 digits we were given. Bottom row, right above your cursor, basically.
Well, 1L.
The 987879992. The answer that we got. That's the 13 digits that are correct. If you go, like it's left and right, it's directly above your cursor, and it's the bottom row. Like it's not row, it's to the right from where you are now. There's 1, 2, 3, 0, and then it begins.
9, 8. That's what we return.
yeah.
So
So
then
the right answer, but it's not.
so we found it. We just have to multiply
those
it now.
numbers. All
Wow.
right. That's very strange. So out of curiosity, I'm gonna paste in my my response here. So I made a problem with link and then problem 8.
So this is how you did it previously.
Yeah. So this is how I did it. This is just brute force. So this is just grab every possible. I'm not. The only time I'm checking for 0 is if this number is 0, I'm just quitting. I don't even care.
You don't care about the next 13 digits, basically.
Right. So so yeah, let me just run this. Alt. I'm curious. I don't store the numbers, but I'm curious if we wrote the same answer.
I'm really confused why.
I know. Yeah, I don't see how this aggregate isn't coming out with the right.
Oh, can you change the x dot length to 4 or 13 instead of 4?
Yes, I can.
Problem 8 with length.
Yes. All right,
Unless
so these are the 13 numbers, and these multiplied together should get this number.
So am I doing it right when I do string.split string.empty?
You have to, because how else does it get
Oh!
the largest?
If all it does is multiply by itself because it's not actually splitting into different characters.
Oh, yeah, maybe.
It's just one string getting returned from the
No.
string.empty.
Is it multiplying a bunch of characters and not integers?
We parse them here. We parse
Okay.
I'm gonna open up C# hat and see what happens.
All right, yeah, go for it. So I'm curious what the actual result of multiplying those numbers is. So I'm gonna, mash it out. So 9 times 8 times 7 times 8 times 7 times 9 times 9 times 2 times 7 times 2 times 4 times 4 times 2. Not the same answer. Did I get that right? 98787 9927 2442. That might just be the largest number, and it's not actually multiplying.
What?
Because I would almost say the largest 4-digit number is that 9989, right? So just because it's the largest number doesn't mean it's the largest multiplication product.
Oh my gosh!
If it starts with 8, it could be 999, and that's automatically bigger than the
I think this is
larger
proof
number.
that my string.
So it might have been like started with a 2 and then it like had a bunch of 9s afterwards or something.
Yeah. So I wonder if I can hijack this and say, guessed.
I'm gonna figure out how I'm supposed to be splitting that string. Because in JavaScript you split it on string.empty and it'll get you in each individual character, but in C# I don't ever do that. So
Yeah, no, neither do I. I've never even used the aggregate function. At least I think I've used it once before, but I just don't even remember what it was. I'm curious what S equals. All right, I just want to x times I times toString. Nope. Nope. Can't remember syntax, man. Oh my gosh. I'm brain farting it. Var char array equals. Nope. Not doing that right. C equals. Holy smokes. Zach. Initialize it in an array for me. I always use link.
how do you slice an array?
No, initializing an array. That's just an empty
New
character array.
Yeah, but
No, it's car, right?
New carpet. You have to.
Oh, right. You have to know the size, of course.
Yeah.
That's fine. I'll just say 13 because it's not going to be bigger than that. Okay. So,
Yeah, string.split is returning a length of 1.
String.split.
String.empty. I'm looking. Looking
okay.
at yeah. So I need to figure out how to.
So maybe what you think? That's interesting. You would have to. I don't know how you would split it. You'd have to just use the array iterator. But then you're not. Yeah, Stack Overflow does a Stack Overflow. I go to Stack Overflow, and everybody else goes to Stack Overflow.
Hey! Guess what it is?
What?
2-car array.
Of course. Yeah, that makes sense. So this is not split. This is. So this might change a bunch of stuff, right?
And you just need to change the list of string array to the list of car array. It's fine to do.
Not car.
Yeah, because that's what it turns into.
Q.
And then you would do q.toString.
Yeah. There was a math version of this where I would get the integer by subtracting, I think it was like a 0 or something, like just a character minus a character. Oh no,
Yeah,
it was like the escape 0, some character. I remember doing
Yeah,
that.
because car is technically a byte. with
Right.
numbers or something.
Yeah. It was an interesting way of converting do to string.
Although I don't know if car is actually considered a Unicode character now in C#. In which case it wouldn't be a byte. But you need to do the q.toString in the other one as well.
Where? Oh, there it is.
So that should provide the correct answer.
All right. But
Hooray!
good job, Zach. See, to char away is how you split a string into a list of characters.
When splitting a string, do not use split. Use this.
Yeah,
Guys, good to
Handy
know.
stuff.
that works in JavaScript.
Yes.
My caveat. It's my excuse.
All right.
It's fine. I use the fact that I work with 3 languages a day is completely acceptable.
We're the last of a dying breed, man. Full
Yeah.
stack developers.
Well, I go from what Android to back to web to Android again and back to web.
That's just full pain development.
All right, what time is it? What are we at?
We are at 8:03 according to my clock. but my
8:03. All
my
right.
clock's a little fast, but that's likely meaning it's just 8:02 instead.
Nice, not bad, not bad. So let's go ahead and punch this in. So 2 3 5 1 4 6 2 4 0 0.
Hey, we're right.
Yay.
I think that's
That was the more, at least a little bit more challenging in the sense of took a little more brain power to sort of
It's kind of funny how making things efficient costs like exponentially more brain power from us.
right. Yes. Yeah, the fact that we wanted to only look at certain values, right? We want to only look at stuff that didn't have zeros because that'll instantly clean it up. And again, the length has to be larger than 13, or else it's again pointless that you do the math there. But then finally we do this. Actually, what we could do is just compare the time on how long.
Yeah,
each
that's
one
what I was
takes.
going to ask. Is so now, well, what we would want to do is we want to benchmark it. So we'd want to get rid of the console.write line, like commented out for now in both of them.
Okay.
Since we know the answer is right.
Yeah.
And then we would do stopwatch loops of like 100 runs for each.
I've never used that. How do you do that?
So var sw equals stopwatch.new, lowercase w,
If you insist.
and then
It's have
dot
to
new.
import it, huh?
Start new.
There it is.
Yeah. And then
It said 1,000 iterations.
sure.
Right. Why did I do that?
Well, you could decrement.
Plus.
And then after the first for loop, you would do sw.stop.
Is there not a lap function?
Yeah, but it doesn't matter.
Okay.
Then you would console.write, write line sw.elapsed. And then
Start it again.
sw.start new.
Yep.
Yeah. Alright.
Is it dot start? sw.reset.
There we go.
And then another right line below that.
Whoa.
Oof.
All right. Shall we?
See which one's faster. I'm going to predict yours is going to be significantly faster.
His
Well, I
doesn't
mean,
have the
link-
splitting.
Yeah, I don't have the splitting. So let's see. Hey, yours got it. Nice.
Oh wow. I'm impressed with myself.
Yeah, I mean, it's just a simple fact that you took out a significant number of comparisons.
Yep.
Okay.
Yeah, if I would have, I think if I just,
If you converted
if I split,
my version to
yeah,
your,
if I just did this part, where am I at? If I just did this part, it might, it might make a significant change.
yeah, if you want to, you
Very
can
cool.
do that. Do you want to do that where you want to convert it to use your logic, or do you convert your method to using my logic?
I might do that later on when I update the code, add some comments, and so people can remember stuff. But yeah, I think that we'll call it a day there.
That's a
And
good stopping point, I think. 8:06.
yeah, it's pretty cool. All right, well, thanks, Benjamin.
Yeah.
Thanks for having me.
Thanks, Benjamin, for hanging out. Thank you, Zach, for consistent input and always unique ways of tackling problems. So that's good.
Lazy ways of tackling problems.
Hey, I wouldn't call it lazy. It took a little effort. It took a little effort, and it's definitely it'll be good to have the comparison where people can see what's easier to see for them, and
Yep.
what's easier for them to read and such.
Yeah.
So pretty cool.
You call mine. You call yours like problem 8 loop instead.
Yeah, problem 8. Yeah, let's call it 4-way.
Ayo. Foreman. You ever see
4-way.
that 70s show?
Yes.
Foreman.
Oh man, that's terrible. All right, again, thank you. We're gonna wrap it up here, and
You want to flash the GitHub repo?
oh yeah, of course.
And then
Should've-
you can flash the
should've-
playlist as well.
Should have had it. Open already. Here we go. Slack. CodeStack, GitHub. Boom. So here we have. Let's go to the one up here. We have the repo here. That's /codestack sj /codestack_meetup, and we'll have every video here, or sorry, every code block here. You'll see 12 here. You'll see mine coming up here probably tomorrow. And as you can see, we have a YouTube playlist here, and you can hop on and see our growing list of videos. So again, thank you for watching, and we'll see you next time.